super excited to have Sergey Pigach back on my show. He's currently Associate Applications Developer at TT Core Studio. And one thing I'm very grateful and I don't thank you enough. So my first hackathon in 2019 we did together in Grasshopper again. And that was my first step towards like software development. And like 4 years
Oh,
later, like I am running a tech company. So like my baby steps into the software development, like all credits goes to you and Charlie. Like we did some really cool project. So thank you.
wow. Well, I'm glad to hear. Also glad to be back. Thank you. This is you know, always fun to chat. So
And for people who already know Sergey on LinkedIn or wherever you follow, he's like hackathon master. He has cracked some code every time in AC Tech. I see like amazing project from him and really cutting edge idea. And he always says like he doesn't have enough time. He might not do hackathon, and at the end he he pursues that part and kills it. So yeah.
thank you. I'm very happy that the past couple hackathons that I was on, our team actually was able to go home and sleep, which is
Ooh.
kind of yeah, it's kind of rare for those types of events. But yeah, I think I should stop damaging my brain cells at some point in life.
Or maybe it because like it's at a time where like you have become like 1000x better developers, so the same things takes now minutes which take hours before.
I've been also partnering with some really cool folks. So yeah, it's I don't know. It's been it's a good time.
I see. So for folks who are like knowing about you for the first time, can you tell a bit about your background, how you started, and major highlights of your journey which led to your current position?
Sure. I mean, as Charlie likes to say, I'm also a recovering architect. I guess at this point, I've been doing software for over 5 years. It's actually going to be 6 years at Core in January. So I've been doing it for a while. But my original background is in architecture. So I I started my undergraduate degree in Canada, actually. So I went to University of Toronto for a couple of years. And that was an amazing school for anything but architecture, specifically design. I mean, like, I don't want to badmouth U of T. Like, I met some of the most amazing professors in history and theory, and there's some really, really incredible kind of theoretical classes that I took there. But like first year, we didn't have any studio or any rep classes. Second year, we had one rep class in the first semester, and then we had like a design studio in the second semester. So after 2 years, I only had one studio. And we also didn't have like our studio space. We were sharing it with artists in the Spadina Circle, this like weird Gothic building at the edge of campus. Um, so, that's what was kind of the time where, I was adapting to, studying abroad and learning English and doing all the things. But also I was progressively getting more and more interested in computation, even though I didn't have an opportunity to do anything. But, I would look at SciArc and look at all the cool things they've been doing. And University of Toronto has this interesting thing that they call the breadth requirement. So as an undergraduate, you have to take courses from outside of your major. So I was studying things like astronomy and geology and psychology and, like all of those like 101 classes that are amazing and are not intended for people who specialize in that field. So it was a great time. And one of the classes that I took, because I needed a science credit, so I was like, okay, I already had a year of astronomy. I'm, Neil deGrasse Tyson at this point. So what do I do? And I found out that U of T is actually one of the top 10 schools for computer science. So I was like, oh, maybe I'll take a coding class. And so I took a semester of Python. And, like I learned enough to be dangerous. Like it was still pretty helpless when it comes to coding. But I think the most important thing that it did for me is that it kind of demystified coding as a process. Like, it was no longer scary. I knew that if I don't understand something, I can Google it, I can read the documentation, I can like tinker and figure it out. And then I moved to New York and I got accepted to Pratt Institute. And Pratt kind of always positioned itself as a very computationally skilled school, so to speak, even though there's quite a range of professors that you'll find from very traditional to kind of very out there. And all of a sudden it's like, oh, Rhino has a Python API and Maya has a Python API, and all of these little things that I learned at U of T, suddenly I can use them to make geometry. So that's kind of where it started academically. And then just kind of to wrap this up, I was teaching myself pretty much. I had a couple of amazing professors, like Azio Blazzetti. I never took his studio, but I took one of his seminars. Dukes and Segway. I know I'm just naming names, but if you're part of the Pratt crowd, you know who these people are, and they're absolutely great. So there were people who are very skilled with making and with computation, kind of parametric and algorithmic design. So that was really great to just have someone who can show you things and just introduce you to concepts you didn't even know were possible. And I almost failed my second year studio because I decided to do my entire project in Grasshopper, a software I did not know at the time. I did not fail, and I learned Grasshopper, so kind of got away by the skin of my teeth. But at the end of all of this, I both had, again, like enough knowledge of all these tools to be dangerous, but also a little bit of a reputation of a person who messes with those things. And then my good friend Leland, who was working at Core at the time, after I graduated, maybe a year, I was working for a small architecture firm. He hit me up and he was like, "Hey, Core is hiring. Do you want to come in for an interview?" And that's like, yes. So yeah, now I'm here.
Nice. And you are back at Pratt teaching now?
Yeah, I'm kind of consulting for morphology class. So I'm the nerdy guy who comes in once a week and shows you how to do geometry in Grasshopper. But
I see. Is it like overwhelming for students, or you like break it down?
I still remember how confusing and intimidating it is to start with Grasshopper. So I try to, be as easy as possible and like try to kind of build it up gradually. It's also hard to teach the tools you need to do your work at school while you're doing your work at school, like during the semester. Ideally, you would have a prerequisite for people to like already know all of these tools. Most folks know Rhino well enough by like fourth year, fifth year. Still, every once in a while, you would see a student who are like struggling with some simple things in Rhino, and you're like, you are graduating next year. Like, how did this happen? And everybody's afraid of Grasshopper. Like, there are very few people who actually play around with it, even though there's been an increase that I can see over the years. But yeah, no, I try to be as evident and transparent with my methods as possible.
I was wondering if you saw like mini Sergey in the crowd, who's like, "Let me break it." This passion. Not yet.
I mean, I don't know what mini Sergey would symbolize in this case, aside from lots of bad decisions. But no, I mean, there are some folks who are interested, like truly interested in computation, which, I actually had this conversation with someone during AC Tech where we're talking about, how maybe, around the time when I was graduating, so this is like 2017, but also earlier, so late 2000s, early 2010s, you would have all these people who were kind of a little bit of an outcast, and they were just trying to tinker with things nobody else understood, including their professors. And now they became people like Dave Mans, who now is back at Pratt teaching. For those of you who don't know, aside from being my colleague at Core Studio, he's also the author of Mesh Plus and a lot of other amazing plugins. But yeah, like it was kind of reserved to a small group of weirdos who had an interest in technology and pursued it on their own time without a lot of external support. And I think we all thought that years later, we would look back at Pratt or just at an architecture school in general and see that now this is the mainstream, right? That now actually using technology to be more efficient in approaching both the production side but also the design side of your project, being able to afford more complexity and like being able to tackle more complicated problems, that would become common. And it really didn't. And I don't know what it is. I still see the same fear and bewilderment in the eyes of students today that I saw, in the eyes of my peers 10 or 12 years ago. I don't really have an answer for that.
Mm. Is it because like there is another wave of like after like computational design, there's now AI in design wave, and like are we like still scared? What do you see among students? Is it mid journey is exciting enough or no?
Um, I haven't really seen a lot of AI being directly incorporated into studio projects. I think there's probably a good amount of pushback that exists from the faculty not to accept something that's generated by AI as like a deliverable per se. I'm sure that people use it for ideation and optioneering and kind of a jumping off point, which I think is good, right? I don't want to make a statement of like this is the right way to use this tool. No one knows what's the right way to use these
Yeah.
tools, but it seems closer to what we would consider acceptable in this context. But yeah, it's a big question, right? Like, which takes us on an entirely different subject. Like before, we were talking about technology and like whether or not people want to explore it and tinker with it. I think AI is a completely separate beast that we're all still collectively trying to understand in terms of its implications long term.
Yeah. One major difference like I found is like, for example, for getting used to Grasshopper, it required set of like knowledge and tutorial like to get like the basic and like because of this conversational AI with ChatGPT, like it's the friction to try out new technologies has gotten way lower barrier. So that's why I was curious. Like now, it could be a friend or an assistant in design.
Yeah, but I think it's also important, if we're talking about AI specifically, I think it's also important to know how to use it correctly and like what are the shortcomings of this technology. And again, like this is as of what is today, December 5th, 2023, right? Whenever you're watching, like just FYI, ChatGPT just celebrated 1 year. Like just over a year ago, we were living in a world where this was not a thing. I don't know, Midjourney came out like 2022 or something, if
Yeah.
I'm not mistaken. So like all of this is very new. And I'm just saying this, as of our current technological level and our current understanding. But if you don't try to use large language models, for example, as a resource for solving complex creative problems or making decisions or doing any of kind of high level thinking that requires in terms of a lot of kind of analytical processing and decision making. I think it would get good results if you don't do that, right? If you're just using it for the purposes of learning, for instance, like I'm trying to do something in Grasshopper, or I'm trying to like write this, I don't know, particle simulation script for me in Python, and GPT-4 would do an amazing job for the most part doing that. And if it doesn't, you can always tell it to fix things, and it will. So like as a co-pilot, that just makes troubleshooting less time consuming and less frustrating, I think those models are amazing. I'm not 100% confident that students currently have the culture, so to speak, to treat those technologies in this way, because we're all used to just using apps that do things for us, and I think there's a bit of an expectation of like, okay, little AI demon, just do this for me. And I also don't think that maybe older generation of teachers and professors who for whom at some point the internet was a big kind of civilizational change in their lifetime, they might also not be prepared to treat those people to treat those tools with the skepticism and care that they necessarily deserve. But if you don't ask for too much and you kind of compartmentalize your problems, I think this could be a very, very powerful aid.
Interesting. You mentioned about plugins. Your like, think Swiftlet got like a lot of like when I was following the conversation, the community really loved that plugin. Can you share like all like the projects you worked in last 6 years at TT, some like highlights, what kind of work you did, tools you developed, what problems it solved?
So from the out of the things that I can't talk about, and I guess I can't really get too deep into the details of some of them, but we've been working a lot on AI, obviously, mostly on structural AI, trying to automate some repetitive tasks that our engineers have to do, for things like member sizing, for things like bay design, and things like that. And there's always a misconception that whenever people think about, oh, you trained the model to do engineering for you, you're a large engineering firm, you probably like parsed a bunch of your old projects and conjured up this model based on like real world data. So we tried that. Doesn't work very well for a number of reasons. First of all, when you have like a cemetery, a graveyard of Revit files that have not been open for, in some cases for almost a decade, it's hard to get this information out. Also, it's not always guaranteed that that information is up to date, that this is not just a Revit model before the engineering results came back for documentation, that it doesn't just have like placeholder columns and beams and whatever. So it's hard to like parse out bad data and filter it out. And also, doesn't really matter how many projects you have. A lot of the buildings are pretty similar. Like if you have a bunch of residential buildings with a particular span, like your sizes are not going to vary that much. So you also have like a lot of concentrations in some parts of the design space, right? And then like large gaps in less common areas, which makes it very difficult for something like a neural network, for instance, to generalize, right? So what we've been doing a lot is generating synthetic data. So we would write our own solvers that can just crunch numbers and run for days to weeks to kind of pre-compute all of this data. And when I tell people that, they often wonder, like, okay, so what's the point if you're just brute forcing, every building in existence? Like, what's the point of training a model? And the point is to save time during inference, right? So if you generate your data, each iteration, depending on what it is that you're sizing and what it is that you're analyzing, it can take minutes to tens of minutes. And when you try to design a building, like, those elements add up. When you train a model based on the clean synthetic data that has good coverage in terms of the design space, you get, answers for large vectorized input arrays in milliseconds. So that allows you to do really interesting things, potentially. So yeah, I work with Core AI a lot. So this is kind of our dedicated branch with people who are a lot smarter than I am, who actually have data science degrees working there. I work mostly kind of on the plumbing side of things. So MLOps, deployments, that type of stuff. So
I see. And can you like share about like what kind of tech stack or systems you use for MLOps or various software or plugins you develop?
So we're building our own MLOps stack, and it kind of runs on top of AWS. So we're adding a lot of tracking functionality to AWS's deployment pipeline. So Amazon SageMaker is, a really nice, fully managed service for, taking your machine learning models and putting them inside of Docker containers and spinning those up and scaling and doing all those fancy things. So yeah, that's kind of
I see.
the core of it.
Yeah. Like one interesting thing I found for people who are doing MLOps for their practices is with AWS, they have like SageMaker or other Docker applications with like that can scale very well depending on the loads. But there is always like one GPU requirement. They have serverless CPU, but like serverless
Mhm.
GPU is not there. So I found a really interesting platform called Modal, which is like a serverless computing platform where you can have like literally zero dedicated GPU and you can save hundreds of dollar of fixed GPU costs, even if you are not running inference all the time. So
Oh, interesting.
yeah. And
Yeah,
it's
it it
sorry.
definitely has a pretty high running cost. Like,
Yeah.
yeah. Um, we're trying to prototype mostly on serverless instances, but yeah, for sure, when you spin up like a dedicated instance or a multi-model endpoint, that adds up quickly.
Yeah. Yeah. And I saw this time in AEC Tech, there was announcement of like TTGPT and other projects. So like what are your thoughts on like retrieval, knowledge retrieval with LLM and some learnings where because like I think you mentioned a very important point about structured data. Like a lot of people think, okay, you go to general contractor, they have like list of line items and then you can train the model. But like sometimes the subcontractors give very abstract way of doing it. So you can't even like go into detail like each item. So there are like a lot of assumptions people make, okay, just feed in data, get structure, but there are a lot of challenges of getting the structured quality and also doing analysis of like whether the data is diverse. So what are some like lessons learned in the knowledge retrieval part?
Yeah, so I think when LLMs became a reality and when retrieval augmented generation RAG kind of
Mm,
became developed shortly after, the most obvious, most intuitive thing that every large company realized is that, hey, we have all of this institutional knowledge that is sitting somewhere, in the cloud or just collecting dust on our network drives. Why don't we, take all of this, put this in the computer, ask computer questions, right? Seems simple enough. And to a degree, it's not a difficult problem to solve on the level of a prototype, right? So, for instance, something that Core AI did, we have an internal internet. Essentially, we have like an internal social network that people use to post updates and post articles or some documentation or have discussions and so on and so forth. So we worked with our IT to collect all of this data for the past 10 years and just have it as a bunch of text files essentially, and then use semantic search to find things that are relevant and then feed that as part of the prompt to the GPT-3 or a GPT-4 model. And it works really well. Again, going back to the limitations of LLMs, like LLMs are very good at processing text. So if you give them an example or if you give them something to read and infer some meaning from that, they will do a pretty good job most of the time. Some of the concerns that we had, which is why it haven't really moved from the point of the prototype, is that we have a lot of documents that can be confidential, and we need to be able to work with confidential documents. Now, the GPT models aren't open source, and even if they were, it would take some serious hardware to run them. And we don't really trust OpenAI that much to send some confidential data as part of the RAG architecture. So yeah, there's some workarounds. Like there's a flavor of GPT-4 that you can get through Azure, because obviously Azure and OpenAI, they collaborate very closely. But yeah, it's there are a lot of unanswered questions there. And also, again, like it's simple as a prototype, but then you start taking into account, okay, so now we have 1,500 people who are going to use this thing, and each API call costs this much, and we have to store this data in some accessible way and maybe use some services to do semantic search and so on and so forth. It also gets pretty expensive pretty fast. So yeah, we're looking into different solutions. We might end up not having to build something ourselves, because also everybody is trying to do this. I think Amazon just recently came out with a tool that does exactly that, but based on what is their model? I forget. Like their competitor to GPT.
Like,
I'm totally blanking. But yeah, anyway, so everybody's going to try to do this. So we'll just going to see what happens.
got it. And you talked about okay, sometimes making prototype is easier, but for production there are a lot more things you got to consider. One is inference cost and also this data leakage. So TT Core Studio has developed a lot of apps in the past, and in the hackathon we see a lot of interesting projects. So what do you think is a missing step where a lot of these ideas can't convert to the production level, or what's the missing pillar?
You mean like hackathon projects becoming actual products?
Mm-hmm.
Well, I think it's in the name, right? Given the given the time constraint of the hackathon, where you're trying to just slap something together in a matter of 24 hours with a team of people you probably never met, things are kind of done by any means necessary, right? Like you get something barely working and not working enough for a demo, and in a lot of cases that's where things end. And also, I think there's a big difference between a hackathon idea, which doesn't need to be constrained by real world requirements of a product, right? Like a hackathon idea doesn't have to be financially prudent and self-sustainable, and like, you're not going to be showing it to a bunch of venture capitalists and whatever. Um, but it just has to be exciting enough and innovative enough to make an impression, right? Like this is the goal. Having something exciting enough and innovative enough to make an impression, but not having a long-term plan for how to make this sustainable and how to make this a business is the reason why most of startups fail. Right? So I think it's just the target is very different for the two of those. That said, I don't think there's anything preventing people from taking a hackathon idea and then spending a ton more time on it to actually develop it into a product. But it's kind of like it takes a very short amount of time to get to like an 80% prototype, and then you spend the rest of your time getting those last 20% that will hunt your dreams, because it's like the edge cases that kill you and prevent you from making a stable product.
Yeah. And for people who are listening, like, can you, if possible, you can share like some timeline about like the product cycle? Because we know the hackathon takes 2 days, but like, does like making into fledged product, depending also like very subjective question, the scope of the product and stuff. How much time does it take from inception to production?
Oof. I mean, I can tell you, based on my experience in Core Studio, you're probably a better person to ask this question to because you're actually dealing with the startup life. Core Studio is a bit of an odd animal because we are not necessarily self-sustaining, right? Like we are part of a large engineering firm that kind of hosts us as an R&D department. So it's different from being 3 weeks away from bankruptcy at any given point, which is nice because it allows you to kind of play a longer game and not necessarily be limited by the fact that your product isn't making money right now. But it's just a different set of pressures. So just like with this asterisk, my experience is a little different. I'd say that we try to start slow. So like somebody would come up with an idea, we would have weeks of discussion before like a single line of code is written, trying to understand, is this viable? Is there enough interest in the market? Who is the audience? Who are we marketing this to? Kind of answering a lot of those basic questions of like, okay, what problem does it solve? Are there tools out there that are getting close to solving this problem? Like, you don't want to find yourself in a situation where you're in a head-to-head competition with Amazon or Microsoft or you name it. And then, once you kind of figure out big philosophical questions, which again takes a long time, then, you again spend weeks figuring out, UI, UX, making wireframes, going through iterations of the design, kind of developing a proof of concept, which, depending on how complicated the tool is, can take anywhere from a single sprint to like a series of sprints. And that's something that we adopted also a long time ago, like working in 2-week sprints. And yeah, it's a very long process, and it kind of runs counter to our inherent curiosity and instinct of a software developer. It's like, oh my god, I have this amazing idea, I'm just gonna like do something right now and it's gonna be awesome. We used to work like that in the past, like way before, and we've gotten ourselves in situations where we would spend time developing something amazing, like truly amazing from the technical standpoint, and something that makes us very happy that we built it, and then no one uses it. So at a hackathon, that would be a successful project because it is technically impressive. As a product, you just spun wheels for a while, and you didn't make anybody's life better. Um, so yeah.
Yeah, that's a really interesting point. Because one thing I find, like, basically, like, in AC tech funds, there's limited like R&D budget, and like for like successful like product, there are a lot of phases, like you mentioned about UI UX, MLOps, and also do firms have product manager to take in charge, talk to the user constantly, update the product, and so how many people ideally you need like to develop a product?
Uh, well, it depends. I mean, we still work with pretty small groups of developers, mostly because we work on a lot of things at once at any given moment.
Mhm.
So, even though, you know, Core recently underwent kind of like a internal merger, we had a bunch of folks who kind of joined us from within um, TT, and I can't even tell you how many people we have now. I think probably over 30. I'm
Oh,
not sure. Um, but, which would be a sizable amount for a startup, let's say. But then we don't just have one product, right? Like all of these people are kind of split around into different teams, and you tend to oscillate a lot. So we have people who are like amazing at backend cloud infrastructure, so they would be jumping between different projects. We have a number of uh, web UI folks who are great. They would be jumping from project to project. So yeah, it's pretty flexible in how we staff things.
I see. And like as application developer, like it ranges from, like you also mentioned about MLOps, which I'm guessing it's Python and plugins in Grasshopper, I know, and Revit mostly is C or C sharp. So how many like can you share like your journey of learning different tools, and what are now effective strategies for you to jump into new tech faster and hack the growth of learning?
Yeah, I think one of the amazing things about working at Core has been, the fact that for the most part, Core is very happy with you learning on the job.
Mhm.
So, you know, obviously there is a cost associated with people doing something they're bad at uh, in order to learn it, right? Because you're burning company's money while you're doing it, while you're learning on the job. Um, but that has kind of been an unspoken policy for a long time that, if you are a .NET developer and all of a sudden you wake up one morning and it's like, hey, I really want to get into the web, or I really want to get into AI, um, Core has been very supportive of those efforts, which I think is really great. For me, it was a little bit sink or swim, I'd say, because again, like when I joined Core, I knew Python well enough and I knew Grasshopper well enough. Like those were my two main credentials. And then I did a bunch of modeling work. Core modeling is kind of a separate branch, also within TT Core, that deals with projects. Most of Core doesn't really directly deal with project work, except for core modeling. So they would help teams of engineers with um, specific jobs. And I did a little bit of that just kind of as an intern on the Grasshopper side of things, scripting some things away. And yeah, I just kind of got thrown into .NET development all of a sudden, and like I'm learning C sharp. Emil Poulsen, who I'm sure you know. For people watching, I know we're throwing out all of these names. I don't really know what to do with it. Like you might know some of these people, you might not. But anyway, there are a lot of good folks in AAC, and I think it's a pretty small town, so chances are you also know these people. But yeah, so my colleague who since moved to Sweden which I kind of half suspect that the reason why he moves was because I kept bugging him with questions about C Sharp. I mean, he moved for personal reasons, but I take part of responsibility that, that decision was influenced by his annoyance. But anyway, so yeah, like I have a problem to solve. ChatGPT doesn't exist yet. Email exists. I try to do stuff breaks, I ask questions, I'm trying to kind of piece together how this thing works. And lo and behold, 6 months later, I'm pretty comfortable doing things in C Sharp. And then, you start working on Revit plugins, which is a real trial by fire, dealing with Revit API. I think in one of my earliest performance reviews, when I was asked what it is that you want to do, and I named some things, and it's like anything that you don't want to do, and I was like, okay, this is my opportunity to say I do not want to touch Revit ever again. And thankfully, I hadn't for a long time. But yeah, and then obviously, Rhino plugin development and Grasshopper plugin development, that all kind of stems from there. So.
Okay. And what excites you right now? What are you, if you had more time or resources, what would you do?
I have been working on a project that I feel weird because I don't necessarily want to announce it, because there's a very high chance that it will not work at all. So it might be smart of me just pretend that it never happened, and if nothing works out, then just quietly sail into the night. But yeah,
I was about to do drum roll.
Yeah. No, but I've been very interested in kind of the analog part of computation. I think it might be my reaction to the fact that things are getting so weird and magical and so high level with AI that we can talk to computers now, like in Star Trek, and it's just deeply unnerving. So I think I've been going progressively lower level to try and understand things and how they work on a basic level. So I've been very interested in something called neuromorphic computing, which is kind of a big conversation in the world of AI. The basic premise is that analog computation is coming back in a very big way, partially because of AI, but also partially because of kind of energy concerns. So I'll explain in a minute. Basically, the idea is that right now when we try to train a machine learning model, we simulate everything. Like in a neural network, for instance, every neuron, every connection, every weight is a simulated entity inside of a digital computer. So it takes a lot of energy and a lot of processing power to keep those things in memory and pass those signals around and calculate those activation functions and whatever. When it comes to something like a printed circuit board or a chip, that is an analog processor, right? Not a digital, but an analog processor. You can treat all of those signals as voltages, essentially, or currents. And, you set up a physical system that allows you, kind of embodies that network that, some estimates I've heard is that, neuromorphic chips will allow for something like 1,000x improvement in energy efficiency and, also large improvement in terms of inference speed and things. Because you're not simulating things, you're basically just following a physical process. So there's a lot of research going in that direction. There's also some startups that are trying to combine digital and analog computers, partially because every signal from a sensor is usually an analog signal that we have to digitize in order to process it on some sort of a CPU, and then glean some results from that. If you are able to process those signals without having to convert things to from analog to digital, then again, you're saving a lot of energy, you're improving performance, and that's really good for like IoT applications where you can have some chip that is mostly analog that has like a sleeping digital part that can run in low energy mode for a long time, gather this information from analog sensors, and then once in a while wake up the digital core where it needs to do some processing or do some stuff. So there's a lot of very interesting research happening there. I don't know if I'm just like, I've been reading a lot of sci-fi and like the Sprawl series that I'm trying to finish, and it's just maybe there's like this part of cyberpunk / diesel punk aesthetic that I find enticing, but also technologically that's just very interesting to me. So yeah, so I've been working on a little DIY project where I'm trying, I mean, like I say neuromorphic and then, take it down 1,000 notches because I'm just trying to do some like iris dataset prediction in hardware. But yeah, I've been having a lot of fun with breadboards and wiring things together. And if it works, you'll see something from me on LinkedIn. If it doesn't work, then this conversation never happened. So.
Like, if it works, like make a really good like product launch video and like.
Yeah, I mean it's not much of a product, and I can show you some stuff here actually. Yeah, so these are my little neurons with like a little, voltage divider for the weights and little circuitry to like do the ReLU activation function and stuff like that. So I don't know. Very high chance that this will not pan out at all.
Okay, I believe in you. It's gonna work. It looks very cool. Like it's maybe like I don't know. Like there are some people who do like really cool lighting on the digital boards. Like it's like simulate the neural pathway so we can visualize how it's making decisions.
I know. Yeah, everybody tells me that to like show ways with LEDs. Like, yeah, let's just get it to the point where the correct diode lights up at the end of this network and make the right prediction. But speaking of which, like we're going back to LLMs and like using LLMs for kind of education or problem solving. Like part of the reason why I decided to start doing this on my own time, just as a fun activity. I'm that much of a nerd. Like this is my fun activity. I was partially addressing a long-running insecurity that I have, that everyone in my family has always been really good with electronics. Like my grandpa back in the day, like some neighborhood kids would like come to his house and he would like solder radio receivers with them, and like my dad was always really good at this. My grandma dealt with also something radio related in the 40s and 50s. Anyway, so I'm like the only odd one out who like can connect a circuit just to make a light bulb light up, and this is the apex of my expertise when it comes to analog circuits. And here I just had this idea that okay, maybe I can try and actually implement like a very, very rudimentary version of a neural network, of a classifier on a breadboard. Let's see if it works. We still will see if it works. But the process for the most part was, okay, so like I have an understanding of how this works from the computational perspective, right? Like I understand the math of it. So I just started asking ChatGPT. I'm like, hey, so I'm trying to design the circuit that will take a signal, and my voltage is a signal, and as an output I need it to be multiplied by a certain factor. What do I do? And it would say, it's like, oh, why don't you use like an operational amplifier and blah 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 blah. And like it's pointless to try to ask it like, oh, how do I wire the circuit, because it will screw it up completely,
Yeah.
right, and nothing will work. But that gives you enough like proper nouns to then go and look up. It's like, oh, what's an op amp? Like, can I buy it as an integrated circuit? Can I, how do I wire it up? So then you do your own research, you get questions, you go back. It's like, hey, I have this IC. Here's the pinout diagram that I downloaded from the web. Like, can you tell me what's going on here? And so if you break down a problem to like small chunks, you can get pretty far. So
Eh,
yeah, I don't know.
and I think now, like earlier, like when in 3.5, it hallucinates spatial understanding, like very bad. Vision is getting a bit better at spatial. But yeah, but as you said, like breaking it down, it's really gives a good seed. You know what you like. Sometimes you don't know what you don't know, so it helps narrow down few topics you gotta explore. We had one question from Meherzad. Uh, how long did it take for you to learn ML methods, adapt to a software development team by just knowing Python and Grasshopper? I think
Well, that was a pretty long journey because I'd say in the beginning, like the first project that I worked on as an intern at Core was Asterisk, which was kind of like our first attempt at this engineering as a service model where you can, Asterisk was really cool. I think Asterisk doesn't um, get enough credit, but it was essentially a web app and a Rhino plugin where you could like reference a massing. It would slice it up for you, give you a wireframe, and then use AI to size it. So with that project, like my expertise in AI was pretty minimal. Like I um, had the stupidity of attempts a thesis project in my final year at Pratt that was based on machine learning, which is like, I think I learned the word machine learning in the beginning of that semester. So, you know, um, architecture school teaches you to be very self-confident about things that you know nothing about. Um, so anyway, so it was a little bit of a dumpster fire at the end. But, it's like I kind of learned, again, just like enough to have a conversation. Um, and I wasn't making decisions about how we should generate our data or how we should train our models or what algorithms we should be picking, because I had no idea. But like our servers were running Flask and I knew Python and I could get on the virtual machine and do some things. Same with plugins, like it's a Rhino plugin, you know so I'm only doing things that are kind of challenging enough that there's a lot for me to learn at that point, but not so challenging that I have no idea what to do. And obviously other people who are a lot more knowledgeable about all of those things, they were responsible for other parts of the project. So I'd say that collaborating on some level, that was pretty quick. Getting to a point where my input is valuable, that took a lot longer. And not to say that my input is particularly valuable right now. Like, once again, I know a lot more about AI than I did 6 years ago, but I'm still not the person who like actually builds models for Core Studio, right? Like I deal with more of a behind the scenes part of the process. So
we don't have a clear how long.
yeah, I managed to did not answer the question at all. I guess my answer is depends, right? Like, again, for some little things, just to be useful with some aspects of the project, I'd say, a few months. And then, being able to have an intelligent conversation about AI and help brainstorm specific solutions, that's, a few years probably.
Got it. And like as we are wrapping up towards the end of the hour, like what's your piece of advice for students or professionals who are right now interested in technology but want to make the leap for software development role?
I'd say that, number one, don't be scared. Like, none of this is rocket science. None of this is as intimidating as it seems. Like, we have a really weird kind of, I don't know if it's Hollywood. I don't know like where this cultural perception comes from that, coding is something that only crazy intelligent people can do. Um, back in the 80s, that was probably the case, like when you were just putting things together in an assembler. Um, like a lot of work has been done for not especially intelligent people like myself to be able to have a job in the industry. It's a lot friendlier and a lot more higher level, and there are a lot more resources out there to help you troubleshoot and understand. So there's no magic there. I remember, sitting in studio, and I would have like my terminal window open, and I don't know, I like install Linux for some reason as a separate partition and a second boot drive on my laptop. So I would be like, you know, hacking the mainframe in Linux, and people would come by and just see an open terminal. It's like, oh my god, are you writing code? It's like, no, dude, like it's just a terminal. Like I talking to the operating system. I could have clicked some buttons, but I just like to type for no reason. So that's first, right? Just don't be intimidated by it. And secondly, I would just say, stay curious. If this stuff is exciting for you, just because, making things work and putting things together is interesting, which it isn't to everybody, right? It's fine if you find technology boring and you just want to use products and not get your hands dirty digging around under the hood. That's perfectly fine. But if you do, just mess around with stuff. Like there's nothing better than trying to put something together, working on some projects by yourself, figuring stuff out. Again, like I think one of the benefits of LLMs is that they actually um, removed a lot of the annoying problems. Like I remember, I know I'm veering off wildly, but follow the bouncing ball. Um, I remember that like when I tried to learn a specific topic by myself, I would get super frustrated. Like I'm trying to follow a machine learning tutorial and I'm trying to install, I don't know, back then TensorFlow, and I can't proceed with the tutorial because I'm getting errors because I don't know, my NVIDIA driver is incompatible with this version and something is broken. So like I have a limited amount of time to do this thing to learn something, but then I get stuck for like 4 hours trying to troubleshoot this really boring thing. And that can turn a lot of people away, right? Just like dealing not with interesting problems, but with stupid problems like that. Um, LLMs help with a lot of that. Like for troubleshooting, even in my work life, but also in, dealing with some projects after hours, so to speak. Um, it removed a lot of that, a lot of those pain points. So there's never been a better time to experiment with things than right now.
Curiosity driven learning, just go all in. That's how, that's the Sergey's way. I have a rapid fire before we end the interview. Just
Oh
get like
god.
5 or 10 seconds. That's the max time we get. All right. Are you ready? So
Oh
it's gonna
Jesus.
be
Yeah.
difficult questions. Best sci-fi film or your favorite sci-fi film?
uh Best sci-fi film, Blade Runner.
Meherzad has one, like as an architectural technologist, academia or industry.
I mean, it's both. This is not a rapid fire question. I mean,
No.
we'll spend another hour, but yeah, I mean, it's both, and they don't talk to each other very well.
You played safe. Uh, I was looking for some hard, bold takes, but okay. Uh, your role model.
My role model. Oh God, I don't really know if I have one. Like again, I can't. I'm very bad at this. Like I'm not gonna fit within 10 seconds. Yeah, I think I just follow a bunch of different creators and a bunch of different innovators in the industry and kind of piece together something that hopefully works.
You can't pass this question. Your favorite Grasshopper plugin.
My favorite Grasshopper plugin. Recently, I'd say I think it's called Clipper, which has like 2.5 components, but it does amazing kind of booleans, curve booleans offsets, and it just solves so many issues. I think it's called Clipper. Go check it out.
Favorite architecture building.
Favorite architecture building. Um, yeah, that's a good one. I would again, like it's. I know you just want me to pick one, but yeah,
I should have some penalty. Right? Every time you
I
exceed
know.
10
Yeah,
seconds.
no, we're just gonna get a huge negative score. Yeah, I'm not even gonna pick. Sorry, it's just it's hard.
In New York. Okay, I'll
I'm
filter
I'm
it
very
down.
I'm very good. I'm very good at dodging questions. There is a okay in New York. There is a tower by Raymond Abraham, somewhere in Midtown, and I don't remember what it's called. Um, but yeah, it's very much kind of you know not, I wouldn't necessarily call it deconstructivist, but kind of along those lines. In architecture school, I was a very big fan of Raymond Abraham and John Haydock and all these folks, like Beast Woods. So
I see,
it's very much in the same vein.
I see. A city you wanna retire.
City I want to retire. Let's see what AI does to the world we live in, and then we'll talk about where I'm going to be in however many decades. I don't know. I'll probably be in New York for a while. I haven't thought of a retirement place just yet.
I
Let's see if I live that long.
I see. It's 2030. One thing in AC tech that won't change, and one thing that will like change the way we work.
I feel like I've been hard on architects this entire time, which is good. I have as much as I love architecture, it's like a very unhealthy relationship that I can't live with architecture, can't live without it.
Are
Um,
we going that architecture profession is gonna die?
oh
No,
man,
no, no. I'm just kidding.
I
Sorry.
thought we were going to talk about this. This is like another rapid fire question. I honestly don't know. My prediction in relatively short term is that as AI gets better and as building configurators get better, I think that the majority of people who actually build buildings, which by the way aren't architects, architects don't build buildings, real estate developers build buildings, will probably feel less and less inclined to hire architects to design most of the things, right? Like if you want to make some money in real estate, you just need to build a competent building for cheap that passes, like checks all the boxes for all of these different criteria. It's energy efficient. It's not going to cost you a fortune running it, and so on and so forth, right? As fewer problems as possible, the greater the benefits. Like optimizing for something like that, I think AI would do a terrific job at making competent buildings, right? Will it make our stomachs churn as people who have all of these poetic ideas about architecture and human experience and fill in the blanks? Probably yes. Is this the reality that I foresee for the majority of things being built? I think so. And of course, you'll probably have like bespoke vanity projects where you have a handful of architecture firms that are big enough and sustainable enough to actually take on those kind of signature projects. It's kind of the same way, like if you want a camping knife, you will go on Amazon and buy something that was stamped with a plastic handle, and it's one of 100,000 or million units produced at some factory somewhere, right? Because you don't need like a status symbol. Like, we don't live in the medieval society anymore. Like, your sidearm is not your status symbol. You just want to carve some wood camping. But if you do want something like a status symbol, then you would find some, I don't know, blacksmith somewhere that will handcraft you this beautiful weapon. So I think this is kind of where we are headed. But we'll see. I don't know. No one knows.
Nice.
Was it 10 seconds? Did I manage?
Oh man, we go deep, but that's good, but not good for rapid fire. But any famous or like memorable debugging story or like hackathon story where like if you close your eyes, like okay, this moment you have a strong memory.
Well, favorite bug story, I'll tell you. That was from maybe 2019 AC Tech Hackathon. So I don't know if you remember Swarm. For folks watching, if you don't know what Swarm is, basically, when Rhino Compute came out, we decided that it would be a good idea to see if we can solve Grasshopper definitions on a Rhino Compute instance. And yeah, like at the time, solving Grasshopper definitions wasn't part of Rhino Compute. So that was our hackathon project. It's like, okay, can we send the Grasshopper definition and some geometry as inputs and then get some outputs back? So we worked with this amazing team. Emil, that I mentioned, he was also on the team. And yeah, like we put together this project. There were some folks who like built out this UI 3D viewer, and we're going up to do the live demo, and this is like the riskiest thing ever. And we're just like, okay, just don't crash, just please don't crash, please don't crash. And we set up some random inputs. We click solve, it fires off the response, and then the whole thing crashes. And we're like, no, what happened? So we're like scrambling to figure out what's going on, and eventually like reset the inputs, run it again, everything runs. And then after the fact, we realized that in our the random inputs that we picked, like our demo was a twisty tower, and it was based on a polygon at the foundation that everything was built from. And yeah, we picked, because we were just like under pressure presenting, like dragging sliders to some random position, we just dragged the slider to 2 to make a 2-sided polygon in which obviously you can't do. So yeah, the 2-sided polygon kind of became a bit of an inside joke at Core Studio. So it's probably
Next
my
time
favorite
have
one.
more restriction over the limits,
Yes.
validations. All right. Anything else which we didn't talk and you want to share on a closing note?
Not really. I think I vented enough of my anxiety about artificial intelligence, and I don't know. I think there was enough of that. It's a weird time to be alive. We'll see what's going to happen. I wish everybody to still be here next year. So,
Next year for sure. It's coming. Like actually, you never know. Like if things are like going very exponential in the AI world, so like
I know, yeah, it's gonna be weird. I think this is the only thing we can say for sure. But well,
Like I've been
give it time.
experimenting with like multimodal AI and like GPT with tool success. So like you can have agents and automate to like next level. So I'm waiting for a day where you get like a scope. Okay. Then it chains an architectural agent, change the structural agent, and like optimize and everything. Is like that day would be interesting.
Yeah, and we just drink cocktails on the beach, watching the AI design our buildings.
Yeah. Okay. Thanks a lot, Sergey, for your time. Always love hosting you. Great insights, great provocative insights for sure. Okay,
It's
have a
great
good
to
one.
be here. So, well, thanks for inviting me back.